Okay, welcome back to another video. Today we'll be doing covalent bonding, the formation and dot and cross diagrams. So here are the syllabus objectives from the GCE N levels. Today we'll be going through two of them, which is the formation of covalent bonding by sharing electrons and the dot and cross diagrams. Okay. For a covalent bond, it forms between non-metals and it occurs by the sharing of valence electrons. Please compare this with ionic bonding so that you know the difference. Okay, let's go straight into an example. Which is an element, hydrogen gas. The first step to drawing our dot and cross diagram is to overlap the valence electrons. So hydrogen is H2, so I have drawn two of them here and I will overlap them. I will then proceed with the sharing of electrons. The electrons that are shared are counted for both. So in this case, you can say that both of them have actually two valence electrons, which is a completely filled valence shell for those with only one electron shell. Okay. So this sharing of one pair of electrons is called a single bond, and we can represent in the way shown in the video. Okay, another example of an element is oxygen gas, O2. So we'll do the same thing. We'll draw two oxygen atoms and overlap their valence electron shells, and we are going to do sharing. After we share one electron, we'll find that, hey, we only have 7 electrons. That's not enough. So what we need to do is we need to share yet another electron. So each oxygen actually provides one pair of electrons to get a stable octet configuration. This sharing of two pairs of electrons is called a double bond. Okay, so what we have here is actually a technique that we can use to figure out the ratio of the atoms in a compound, and also to find out the formula. However, for certain common compounds in the N-level syllabus, it is actually easier for you to simply memorize the formula and then apply what we have learned. On to our third example, water, which is a compound. So I'm going to use the table here. Okay, so we can fill up the number of valence electrons, the electrons required, and from there you see that oxygen requires 2 electrons, but hydrogen only requires 1. So what this means is that in order for oxygen to obtain a fully filled valence electron shell, it requires 2 hydrogen atoms to share electrons with it. So we can get a formula of H2O for water. Okay? So this means that the hydrogen shares 1 and oxygen will share 1 electron with each of the hydrogen atoms. So the dot and cross will be shown to you. First step is the same. We are going to overlap all 3 atoms together and we are going to start sharing electrons. So for each of them, it must be shared equally. Hydrogen gives 1 and oxygen gives 1. And doing your counting, you will see that hydrogen has 2 valence electrons and oxygen will have 8 valence electrons. Here we have 2 more examples of covalent compounds, ammonia and methane. You should memorize the formulas for this. Okay, so for this type of compounds, the one in the middle is usually the one that requires the most number of electrons, and you will just continue sharing equally for each atom until they are all fully filled. So here's a little question for you, carbon dioxide. Can you please try this, and the answer will be at the end of the video. Okay, this is how we name our covalent compounds. Most elements exist as diatomic molecules, so you will see that in table A, like hydrogen is H2, F2 and so on. Whereas for other covalent compounds, they will have prefixes such as mono, di, tri and tetra. So you can see these examples and you can see that some of them like water, ammonia and methane, we do not use this naming convention, but rather we have common names for them. So that is why you should memorize the formula for these 3 compounds. Okay, that's all for today. So just check your answer for the carbon dioxide. Did you get it correct? Okay, so carbon dioxide has a double bond between the carbon and each oxygen atom. So for the next video, what we'll be doing, we'll be comparing the properties of covalent compounds and ionic compounds.